Hello everyone, welcome to the new video of the DSAT. So in this video I'm going to make a simple potential production X file. So XBuild, we are going to use a tool in the DSAT XBuild, which is used to construct and modify the file X or experimental file. The simplest X file describes the crop production limited only by the genetic potential of the crop and the environment exclusive of the rainfall. So we will continue to work with the our X file here. So let's open the DSAT and click on the crop management data. So this is your X build and how you are going to make a new X build here. So just click on file, new, close. So we have to select here which file we are working. So in this case we are working with the experimental file, so we have selected experiment. In case if you are working with the sequential, season or spatial entering, you have to add those, but in this case we are adding only the experimental file here. So by clicking here on the experimental file, so let's name the first experiment name here. So just write it has a potential production, and the institute code we can add. Institute code has a UF, which means University of Florida, and the site code we have to give to the site code has site code means has University of Florida main campus in Gainesville, so we are going to use GA. And let's talk about the year. So let's talk about the year 1982, sorry, 82. Experiment number, this is our first experiment number, or we can I rather name it as 11 or 12, like this would be the series of experiments that year for that site. For example, we are conducting 11 number of experiment or whatever, so let's say we add 11 here. And for the crop we are going to select here is maize. So people, you can add here any name. For my case I'm going to add Dr. Garrett Hogenbaum. So address and site you can add, has many details here. For the next, for your remember, like if you want to remember which people did conducted this experiment, that will appear in the description. I will show you later. Address you can write it here as University of Florida. So Gainesville, this is my site. So these the, the information which with the historic sign are compulsory for you to enter. So I have added these information, but for you to add this information is not necessary because these doesn't require any historic sign. So you can also add here your plot information, your harvest area, like your plot was 2 acre, uh, 2 acre, and your harvest area in meter square was only 1000 or 10,000 meter square. So then click on next. So then you have to select the cultivar. Let's say I'm going to work with the McCarty cultivar here, McCarty 84. You find out here. So this one is the, I'm going to use this one. So this one is the management in the cultivar. Click on next. So now you have to give the 8 characters. So now I'm going to give 8 characters in such a way that the first 2 digits will represent my UF, University of Florida, GA, Gainesville, and then the remaining 4 digits you can use with the your information has the year. Like you can see at the top here, UFGA, it automatically creates your field 8211. So 8211, you have to use the same digits. 82 means the year and 11 is the number of experiment. Dot mzx means mz means maize and x means x file. So let's add the weather file here. So we can also add here, that would be, it's not necessary that you are going to add the same field ID. For example, UFGA is your code, but you represent it as 001 first experiment. It doesn't mean that this would be the same as your file name. This could be the different 8 characters. So let's find out about the Gainesville. So UFGA, so we have to select here Gainesville, Florida, and then you have to go to year 82, select it. You have to, if there is any drainage you can add here, otherwise it's not necessary. So then this is the name of the soil you want to add. So just click here and press D. I'm going to use the default. So deep silt, it will start with deep silt soil.sol, but I'm going to use default deep sand. So this one you can see here, and here you can select the code. You can match the code here with your already made file IB0001. As you know, this would be the 10 digits. The first 2 digits would be your site identifier, then the first 4 digits remaining is your site identifier and your location, and the like the 5th and 6th digit is your year, and then the remaining 4. So it could be anything, but this is the, I have already shown you in the previous video, which is the how to make the professionally this code for your soil profile. So click on next. So you can add here as a name, this is your level 1 potential production. So the planting date is the, now here we have to add our planting date. So let's add with the starting, we know that this is month, so this month is 02/26 February 1982. Emergence date if you have, otherwise you can leave it blank. Planting method, it's dry seed. Planting distribution, rows. Planting population at seeding, you can write 7.2 in per meter square, how much plants were available, how much seeding you did. And at the emergence you can put the same, or if you have noted, otherwise you can leave it blank, there is not any issue. Only the hysteric signs we need those information. So row spacing, let's say 61 centimeter, as the unit is mentioned already. Row direction is 0 degree from north, and planting depth is 7 centimeter. You can see the unit here, 7 centimeter. Press OK. So now your file is already created. Now we have to add some more. Now we will go through one by one. Let's click on field. So you can see Gainesville, this is the weather station, this is the soil, this is the field ID, initial conditions of the soil if you have, otherwise you can leave it blank. So in the initial conditions, so the measurement date could be the same as your planting date, but it should not be later than the planting date. The same day of planting you did your measurement for the soil analysis. So let's talk about here with the, so if there is any crop residue, you can select which was the previous crop. There was a maize, alfalfa, or which one, or you can even select fallow. You can select fallow here. Otherwise, if you have know what was the previous crop here, so you can just select maize, because it was a continue sowing of the maize. If you know the water table depth, let's say you have a crop residue of 1500 kg per hectare kilogram. In this case for maize it is normally acceptable. Otherwise, if you don't have any this information, you have to leave this blank. If you have original information with you, you can add here anything. So then what was the residue here? Let's say incorporated was 100% with the depth of 15 centimeter, and residue let's say 1.5%. So let's add here the residue has a 1%. So then go to profile, and you can see here your measurement date. And if you have water available 100%, let's say 100%, and nitrogen has a let's say it's about 20 kg, you have to go through the proper scientific procedure by converting into the nitrogen kg per hectare, where it's an estimate. Like, it's not an estimate, but you have to go from the proper calculation. So if you click on recalculate, this will recalculate your all the values: volumetric per water cubic centimeter per cubic centimeter, ammonium gram, nitrogen per megagram of soil. Remember, this is a megagram of soil, don't take it as a milligram. And then press OK. And then we did the soil, and if you have any soil analysis, otherwise it's fine, you can leave it. Press OK. Go to management, cultivars, we have already McCarty 84A cultivar. Go to planting, let's check it again, we have already entered these details here. So let's go to irrigation. Now, before going to irrigation, if you have done irrigation either on reported dates or days after planting, from the days after planting you have to add here 0. Otherwise, if it's a rain fed experiment, you have to leave it remain, or you can add your remaining dates, like the first, what was the amount of millimeter and what was the operation. So in case of efficiency fraction, you have to see either it could be 1% or 0.95, whatever it is, it should be 0 to 1. So let's go to the treatment, go to simulation options. So your simulation date should be 1 day prior to the date of planting. So we were planting on 26th, so this should be 25th. So this is your year, for how much year you want to run. Replication option, yes, we want to see nitrogen. Either you want to see the effect of water or not, no, you can select, because this is an potential production experiment. We can select no, symbiosis no, and to all the, except for the tillage, you can do it yes or no if you are doing any tillage or not. So then go to methods, we have a measured weather data, photosynthesis, series, Ricci series, modified soil profile, soil conservation, keep it remain everything as it is. And then go to planting, we have already mentioned the planting date on reported date. Otherwise, we can also select automatic window for this. So but here we have already mentioned the planting date. So irrigation, so in irrigation you have to select it's rain fed, then you have to select not irrigated. If you are going to say that I did irrigation days after planting or automatic when required, then there's a, for example, if it is this is a rain fed experiment, you have to select not irrigated. If this is a, you have selecting days after planting, then you have to go here and add your, select here option here days after planting, and then you have to add the day first would be your 0, 1, 2, 3, and then amount of irrigation, amount of water in millimeter, and operation. Otherwise, go to simulation options again, because we are going to, let's say we are going to irrigate it as automatic when required. So management depth, to what depth you are going to irrigate your soil. So let's say 30, you can say here as a 20. And what was the threshold of maximum available, like when the irrigation, when should be re-irrigation. It means that if in the top 30 centimeter of soil the water content reaches to 50%, then there will be irrigation. If it is 51, 52, then there will be a no irrigation. So I'm going to explain this point again, as this is a very important point. We are going to management depth, are selecting has 30 centimeter, okay, and then like in the top 30 centimeter layer there will be irrigation, okay, that's fine. Then to what extent there will be a, as we are selecting automatic irrigation, so when there will be a second irrigation, until and unless in the top 30 centimeter layer the water con percentage reaches to 50%. If it is reaches 50%, there will be a irrigation. Otherwise, if it's more than 50%, there will be no irrigation. Endpoint until it reaches 100%. You can select here sprinkler, fertilizer, on reported dates, not fertilized, or days after planting. Let's say you are saying here that we are fertilizing it in not fertilized. Let's say we can, if we click here on reported dates or days after planting, we have to go back into the management and click on fertilizer, and then we can add our management here, how which fertilizer we are going to give in which dates, either on reported dates or days after planting. Remember, whatever you select in the management here, in the simulation option, you have to select the same option. So let's say we don't want to add here anything, we'll leave it empty here. Just go to simulation options again, management, fertilizer, not fertilize, or on reported dates, let's say not fertilize. Organic amendments, we are not adding any amendments here. No application, harvest at maturity. So then we will click on output, frequency of output days, that you want to look at your simulation in which way, like per day, in each day, overview yes, summary yes, growth, carbon yes, everything. Hence you can, if you want to, if this is a potential production, you can click on no, no, nitrogen no, phosphorus no, chemical normal output, press OK, and then we will go to the treatment here. So you can see this is your simulation 1, as it is simulation 1 here. It's, you can name it by yourself. Let's say we name it as potential production, and then we will go press OK, and then we will go to treatments. You can add here your potential production in description. So cultivar, we only use is the select cultivar field. There is only one field, so we haven't given any name to the field, otherwise it will appear here. Let's say you give any field your name. So let's say I'm going to give here just GA Gainesville. Always press OK whenever you made some entry or changes in it. Then go to treatments. So then you will see here your GA field. If you have a multiple field, so in this way you can differentiate between your field. Soil analysis 1, initial condition, there was initial condition we give, planting and which date we provide potential production, irrigation, there was no irrigated, fertilizer, residue, tillage, we have to leave them, simulation controls. So press OK, we click on file, save, press OK, refresh it once again, and close your file here. Then we will go to serial, maize, and at the end you can see your potential production experiment here. If you click on here, you can see the people, university address, site, and the different basic information about it, the treatment, cultivars, which cultivar you use, McCarty 84, field, this was the field. Let's click on here, run, click it. If you select multiple options, it will give you error, so it is always advisable to click on refresh button here and then go 13, run. We will going to run the model. The simulations are completed now. Press OK, go click here analysis, and if there is any error in our experiment, it will appear here that this was your error in experiment. Plant grow out, we will click on plot, as there was not any in the overview video. I have and told you that if there is any major data available with this file, it will appear bold, as we have not added any average or T file with it. So just this is consider it as simple. Let's look at the leaf area index. Click on here, leaf area index, press next. So this is your leaf area index for the days after planting at 0 day, 20, 40, 120. Or if you want to see the options, if you want to see the date here, you can click on date, press OK. You have to click next again, and it will show you that the day it was 26th of February it was planted and harvested around 8th of July. Then click on cross. We can go here on the summary file, or just go to overview file, click on view. It's overview.out. So you can see here the basic information about it, that what was the yield for this maize. It's around 12,210 kg per hectare, and this represents you that what was the average temperature during the different periods growing stages. So you can see the antithesis day has, why it is appearing -99, because we haven't added any ever major data with this file. In the next video I'm going to show you how you can add your file and different things. So this is your antithesis day, physical maturity, yield at harvest, number maturity. This is your final output. So it started simulation at 25th of February, started simulation. We did sowing at 0 day sowing, and then it appears here harvested at 127 days. So it took 127 days to harvest. And what was the biomass, leaf area index at that time, and any stress. There is no stress in the crop nitrogen kilogram per hectare, as we switched off in the simulation option, we cannot see it here. So this is your file. Thank you, sir. Thank you very much for watching this video. Maybe I'm going to, in the next video I'm going to show you how you can add your multiple fields in this video.